So, start recording. Hello, YouTube. Let's start with the 7th advent of code. Let's go. You land at the regional airport in time for your next flight. In fact, it looks like you'll even have time to grab some food. All flights are currently delayed due to issues in luggage processing. Due to recent aviation regulations, many rules, your puzzle input, are being enforced around bags and their contents. Bags must be color-coded and must contain specific quantities of other color-coded bags. Apparently, nobody responsible for these regulations consider how long they would take to enforce. Uh-oh. For example, consider the following rules. Light red bags contain 1 bright white bag, 2 muted yellow bags. Dark orange bags contain 3 bright white bags, 4 muted yellow bags. Bright white bags contain 1 shiny gold bag. Okay. These rules specify the required contents for 9 bag types. In this example, every faded blue bag contain other bags, is empty. Every vibrant plume bag contains 11 bags, 5 faded blue, 6 dotted black, and so on. You have a shiny gold bag. If you wanted to carry it in at least one other bag, how many different bag colors would... Okay, you have a shiny gold bag. If you wanted to carry it in at least one other bag, how many different bag colors would be valid for the outermost bag, for the top level bag? So, in other words, how many colors can eventually contain at least one shiny gold bag? So here you have the shiny gold bag, blah, blah, blah. So you want a rule where the shiny, so you need to build a graph, and then you want to walk it upwards to find which other bags contain this. Oh God. Okay, we have jumped. There's a jump of complexity here compared to what we had until yesterday. Fine. If you wanted to create blah, blah, blah. In the above rules, the following options would be available to you. A bright white bag, which can hold your shiny directly, and then a dark orange, because that contains yellow bags. Where is it? Bright white, muted yellow bags, either of which could then hold your shiny gold bag. A light red bag, which can hold bright white and muted yellow bags. Right, because so the reason why you cannot have like a white bright can hold directly. So in any case, okay, any bag can be the top level bag, but the graph is not necessarily all connected. There can be like some, like you can have a green bag that contains a red bag, and the red bag contain like a blue bag, and that's it. And like so you have this chunk of graph somewhere that doesn't connect to anything else, I'm guessing. So in this example, the number of bag colors that can eventually contain at least one shiny gold bag is 4. How many colors can eventually contain at least one shiny gold bag? Question mark. The list of rules is quite long. Make sure you get all of it. Holy shit. Okay. Okay. Let's copy all. Should I start with a simplified example? You know what? Maybe it's worth starting with a simplified example this time, at least for me. I don't feel ultra confident with doing this kind of stuff with this, so let's take it easy. So, micro, open source, it's day 7. Could be something for logic programming, probably, etc. Oh yeah, with Prolog that would be you could probably almost copy paste that stuff into Prolog and you're basically done. Like you change is to like open parentheses, chuck a question mark in there, and you immediately get everything resolved. Yep. So I would say Zig is not the language where like you get this immediately. Yep, it's micro. Sorry. I have Space Vim here, but no, thank you, not yet. Maybe in the future, maybe CAC. I don't know. We'll see. Yeah, was tempting me with Kakon yesterday, so we'll see. Then we want a tab, and here we want to open another file. We're gonna call it bags day 7.txt. Okay, as usual, const data embed file source bags underscore day 7.txt. Okay, so how do we represent a graph in Zig? There clearly are multiple ways of doing this. Let's see if we can get away with something easy and dumb. Nothing really comes to mind. So one way of doing this could be, so we don't know how many colors are there, right? Oh, can I paste? Yeah. So in this simple example, we know, well, we can kind of easily inspect how many colors are there, but we don't know how many there are in the total thing. So I think we might want to keep the names around, which is easy. Maybe for the buggability purposes. We could actually like somehow hash them, but we wouldn't really solve anything. So what I'm thinking is we can make our graph and we use a hash map to store links. So we kind of say it like this, like const bag, let's call it, I don't know, bag rule. It's a struct that says color, that's our color, and that's a string. And then for the connections, so we can say, is it can or must contain? Yeah, must contain. Or you know what? Let's just do contains. It doesn't matter. Like we don't know write a real application. So okay, contains, and here we put a hash map. So std.string hash map, I believe. Okay, I kind of regret not having ZLS and stuff. Isn't it just a list of edges? Isn't it just a list of edges? It could be a list of edges, but okay, that's a good question. Do we gain anything at making a hash map? I was thinking that the hash map lets you more easily check if something is in the list, but who cares? That's a good point. Who cares? We might. Well, you don't have to write the search, but do we need to search? We would need to search to build a graph, though. Like as you build a graph. It's a tough question. That's a tough question. That is indeed a tough question. I think it's easier with the string hash map, because then you can just pass it and you don't have to write the search yourself. I don't know if this is like big enough to be algorithmically, well, the actual input code. I don't know if that's big enough to make it like computationally unfeasible to do like array scanning all over and over. Probably not. Probably it's fine. But it's one less equation that it's like one less failure point for me. Like I leave the searching to the string hash map, so I don't have to do it myself. I don't know. Either way, it's fine, I guess. So I think that's kind of the signature. If not, I'll have to think about it. Maybe let's call it const bag rule map is this. We have bag rule map, and that's it. We have our top level, I guess, bag rule map. So var rules equals, and we need an allocator. Cd, hey, is it heap default allocator? I don't remember, and there would be one moment where having tooling installed would have helped. But it's fine. We can go check stuff out. Oops. Library, standard, heap. No, heap. Oh yeah, right. General purpose allocator. General purpose allocator. And is this a function or is this, or does it have an init? I think it has an init. I think it's like dot init, and then you need to pass it another allocator. It's gonna be std dot heap dot page allocator, I guess. And rules is std dot string, well, var rule. Oh, there you go. That's the typo. Bag. Okay, so bag rule map, and we pass to it allocator, which I guess it's unlock. Oh, it should be like GP. It's been a while since I used allocators. Is that it? Am I doing something bad? No, I should not be copying this stuff out. I don't remember. Keep current purpose allocator. So let's find a test. So GPA, current purpose allocator. Oh, it takes a test config, which don't. And then GPA.allocator. Oh, you really? Wait, test config? Oh, you don't need to pass it anything? Okay, cool. I don't know why, but I have a feeling that this is wrong. Okay, so I'm passing the allocator. We defer the dot the init the allocator. Why am I using the general purpose allocator and not an arena allocator? I kind of think that I should be using an arena allocator. That's easier. I think that's what I'm gonna do. Which one's std dot keep dot age allocator? Okay, so we don't have to free anything. So we have our allocator stuff, I guess. Then, assuming everything is correct, what do we do next? We need to start parsing. So for each line, we find the name. So we get stuff until bags, and that gives us the name. Also, do we know if the colors are always couples? Faded blue, vibrant plum, dotted black, muted yellow. Do we know if that's the case? It's like bags contain. That's what we're looking for. Ah, that's so annoying. So let's see. Gotta DM1 is smooth and so jealous. Um okay, yeah, let's start parsing. So what's a good way of parsing then this stuff? Do you have anything in mem that can help us? Validation allocator, no. Validation wrap online and copy backward set 0, 0 init order less than equal index of this compares to slices and returns the index of the first inequality. Span z, len z, index of sentinel, all equal dupe z, trim left, trim right, trim, index of scalar, linear search for the, okay, linear search for the index of a scalar value inside a slice. No. Index of any. No. Index of any pose. Index of haystack needle. I think that's what we're looking for, I guess. Because needle is so it tries to find in a longer list a shorter list, I guess. Well, in a longer slice a shorter slice. So our needle is we want bags contain. We could also search just bags. So if we just search bags, we search bags once and we get this. We search bags again. And we get a number, which can be also, I think it can be more than one digit. And then we get another name. So this parsing is so annoying. So index of gives us the actual index, okay. Is there anything else? Boyer Moore or spool preprocess reverse, okay. Last index of pause. Uses Boyer-Moore horse pool algorithm on large inputs. Index of no, that's not what we care about. Count. Read var in. This is definitely one situation where Mecha from Hazel is definitely useful. Anyway, so we want to do we keep searching for bags? I think we need to search for bags twice, and then we need to find the dot. Is that it? No, we keep searching for bags all the way. Okay, so var it equals std dot mem dot we still need to read line by line, I think. Yes, because we don't know how many of these. Oh yeah, we need to keep searching bags until oh no, we need to search bag and also singular. Okay, we need to search bag until we end the line. So std mem tokenize, I guess. Tokenize what? Data. using what? New line as a separator. Then for it.next, so for each line, what we do is can we assume that everything is two names? Ways? Striped olive, light bloom, vibrant, blah blah. I really think that it's just always two names. So we can do space. No, it doesn't matter because we want them together, right? So I search for bag. This gives me this index, and I know that this is gonna be my thing. Then I get bags again. But if I search bags again, then I'm gonna have contain and then no other 5 faded blue. Oh, this parsing is super tedious. Oh, it's always the name, two names indeed. Okay. Okay, so let's start with the spaces then. So I get the line, and then what I want is const color. My color is well, I guess I need to initialize var. Let's call this line IT maybe. So var IT equal std.mem dot tokenize line on the space. So the first space that I find, I don't care. I care about the second space. So it.next, and we assert that it finds something. Then the second one is the one that we care about. So let's call it like const last is it.next. So this is the second word. And we know that color then is return line slice from 0 to to last.len. So I skip the first space, I get the second space, and then I grab this, including the m. Okay, that's one thing. That's our key. So let's call it like key color or outer color. Let's name it outer. Wow, Prabhat! Thank you for the raid. Hello to everybody that just joined. We're doing the advent of code in Zig, and you join at an interesting point in time because we're doing kind of high level stuff like with graphs and stuff, except that Zig is a fairly low level language, so we'll see how things go. For now it's going well. So outer color. So since there are so many people joining just now, let me quickly reiterate where we're at. So we have day 7 of the advent of code. And actually, let me take another step back. So the advent of code is an advent calendar of programming puzzles. Every day you get a new puzzle, actually like 1.5 puzzle, and you have to solve it. And that's the point. We have a private leaderboard for Zig, where basically the idea is we try to solve the advent of code just using Zig. We don't use other languages, and it's an excuse, you know, to get some more Zig practice. If you don't know anything about Zig, you can go to ziglang.org, where you'll find the website, which we are in the process of redesigning. But it tells you, you know, things that you can do with Zig and general philosophy of the language. So now I'm solving this exercise using Zig, and the exercise in this case, it's a bunch of rules written in somewhat natural language. And that would be a great fit for Prolog and similar languages, where you basically can almost drop in this set of constraints and immediately get the answer unified by it. But in my case, I don't have that. So I'm making do with graph and nodes and hash maps. Probably thank you also for the follow. And so thank you, Kesebrot. Thank you for the follow. So it looks like Rust. In a way, it's kind of similar if you want. It's similar in the sense that it's like a modern age systems. It's a modern age programming language that you can use for systems programming. Unlike Rust, it's easier to get started. You can really learn Zig in a weekend, and it doesn't have any borrow checker thing, so you don't fight the compiler as much. There is a different model when it comes to safety and stuff, but it's a different brand. If you want a super coarse, so very imprecise way of describing it, but like just to get a super initial impression, Rust is more C++y, so it's like a bunch of generic types combined together, type constraints, a lot of like coming up with complex generic stuff that through the type system ensures a lot of properties. Zig is a bit more like C. Like we have metaprogramming, we have like generic style metaprogramming, not with the angle brackets nor with macros, but you can pass types as normal values and normal arguments at compile time. But the result is that you tend to write something that is more similar to C than it is to C++, maybe. It's not a very precise way of describing things, but hey, as a starting point. Oh yes, it took me a month to start writing compilable Rust, yeah, and half a year to get something working. I assure you, for about 1 weekend, you can get the ground running with Zig. It's just so nice. Actually, keeping the language small and simple is one of the main stated goals. Let me bring up maybe the new redesign. Let's see if I have it here. Do I have the redesign here? Oh well, I do have it in any case for sure. So let me bring up Discord server. We have a channel where we discuss the redesign, and in here I pinned a link to the preview. And here you can see the preview, which, okay, this is in the actual way in which you would see it. So the idea is it's general purpose programming language for robust operational software, a simple language. Focus on debugging your application rather than debugging your programming language knowledge. No hidden control flow, no hidden memory allocation, no preprocessor, no macros. Yeah, when I tried Go, I did a 3D Ray Marcher 2 hours into learning the language. I would say that Zig is probably... So I also had a good time with Go. I would say that there was a couple of idioms from Go when I was learning that kind of threw me off for a while. Like, but maybe it was just me. Like how certain things are special case, like maps have their own weird syntax and stuff. Nothing major, like small things. But with Zig, you have a bit more. Like there is comp time execution, which really like you're allowed to run functions at compile time and use those functions, for example, to do generics. Like learn code examples. So this is a code example where there's this queue, and the queue, it's this is a generic type. Actually, let me see if we have a simpler example somewhere. I think we have it in the documentation. So actual website, documentation, comp time. So comp time is basically you can run functions at compile time, and that can be useful in general. So you can imagine 1 or 2 times where you wanted like to compute something once at compile time and not compile it and not recalculate it every time while the application runs. But more interestingly, let's see if we have here the example of a linked list. Fibonacci. We used to have a linked list here somewhere. First and primes. There we go. So here's the idea of a generic list. So instead of declaring a struct, so this is the syntax for declaring a normal struct. If you want a generic struct, what you do is you create a function that takes in a type argument and returns a type. And the type that you return is the struct that uses the argument that you're given in. Like you normally do this with like angle brackets, but then if you use angle like in other languages like C++, but then when you have the angle brackets stuff, you're kind of limited in the type of reasoning that you can do with those arguments, because they are kind of like a simplified templated version of the language. Here, the type T is an actual value that you can inspect, reason about, and do a bunch of very nice stuff. Long story short, it's like it's an interesting mix between comp time dynamicism that usually you don't have access to. Like comp time Zig kind of looks like Python, if you will, to some degree. Thank you, Ripsico and Greenmine, for the follow. Welcome to the stream. So you have a lot of power at compile time, but then here's the interesting thing. Those types, like the type information, doesn't survive runtime. The type information disappears, evaporates, and all you're left is with actual machine code, no runtime. Like Zig doesn't have a runtime, and everything is decided at compile time through the system. It's pretty nice. You can do like, it's a very nice balance between like expressiveness and being able to actually define constraints on your code, not having to use like void pointers like C does all over the place. But on the other hand, like I've been annoyed, for example, how well, we were mentioning Go earlier. I like Go a lot, but one thing that I always found kind of annoying is how you don't have generics. So you need to do like sometimes casts from interface or like JSON parsing libraries tend to do a bunch of reflection at runtime. Here in Zig you can do reflection, but at comp time, not at runtime. And I think these are all pretty cool things that strike a curious balance. So I recommend to check it out if you've never seen it. Or you can watch me fail now at the advent of code. So what I'm trying to do here is to parse one part of this file. And if I wanted to do this, sorry, I also have it. So I simplified the example copied here. So you have a set of rules like light red bags contain one bright white bag, 2 muted yellow bags. So all the bags have all these colors, and there are a set of rules about which bag can contain, how many other bags it has to contain. And I have to answer a question about how many combinations, how many outer layer bags, how many different colors the outer layer bag can have so that it contains a shiny gold bag. That's the question that the advent of code gave me. And if I wanted to do this in Zig, like in the proper way, the first thing I would do is that I would go to GitHub and I will search for Zig Mecha. And there's this parser combinator library in Zig, which kind of appropriately, well, it's kind of obvious what it does. Right? If you've never heard of parser combinators, maybe not. But the idea is you have a bunch of like smaller parsers. Like this is a parser that only accepts a hashtag. This is a parser that accepts one of RGB1 or RGB2, which you define like this. Everything combines together, and then you basically create a parser for a proper grammar just by combining simpler parsers, which is a great approach, especially when you're doing this kind of stuff. So what's funny is that I think parser combinators in lower level languages, like languages with manual memory management, usually are kind of annoying and unwieldy. And I don't know, I haven't had extensive experience, but the little that I had wasn't particularly good. And in higher level languages, they're awesome because you can do whatever you want. In Zig, basically, this parser stuff happens at compile time. So you can, I think you can even see here. So this code snippet here as a test. So this doesn't have a main function, which means that it's like a code, it's an example. And as an example, it doesn't compile to an executable because it's missing the main function. What's outside of the main function only runs at comp time. So like this is the equivalent of declarations in C put outside of the main function. But here you can have a bunch of like functions that actually do stuff. And the way you would run this snippet of code in reality would basically, you would do zig test and then name of this file. So it would run this test block as a main file, or like you could have multiple test blocks one after another. So my point here is this stuff here, like composing the parser, happens at compile time, which is pretty cool. Like you don't have runtime, you don't waste runtime resources to build the parser again every single time. So I would use that, but we have a rule in our private leaderboard where we should not use external libraries. So I'm doing this the manual way, very not robust, but hey, it's just to get the final answer. Like the point of the advent of code is that you're not writing a program to, like, you're not writing a robust program that can be used on that entire class of inputs. It's fine if you just want to extract an answer from the input from your specific input, because your goal is to being able to answer that question, which says how many bags can eventually contain at least one shiny gold bag. You put in the answer, and then that's done. Your code. That's the final use of your code. So what I'm doing here, I'm grabbing the file line by line. I'm then splitting it on spaces. I'm skipping the first space. I'm grabbing the second space, and I'm using the second space to grab the entire color name. So this tells me the color that on the outer level for each line, for each constraint expressed in a line. After that, so now I have the outer color, and this syntax here, block, this is not return, but this is break plk colon plk. So this is a labeled block. So the idea is sometimes you want to have blocks to shorten the lexical lifetime of a variable. Like you don't want, if you're creating a bunch of variables that only like live for a short while and then you don't use them anymore in the rest of the function, sometimes it's nice to do this so that you know that they're in here, so they won't survive and you don't have to think about them later. Mostly the reader won't have to think about them later. Label blocks go one step further, and the idea is sometimes you want to have one thing that survives though. And I think I've like, for example, in Go, I've done this. I've done like var foo type, and then underneath blah 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 blah, and then finally foo equals var. And the problem is, like, what if you forget to initialize this? Like, you see that you created foo here that doesn't have any value, and there is no way of enforcing that the value has to be set. Maybe you have a bunch of conditions and you don't notice that one particular branch doesn't set the value. Label blocks force you to make sure that every path, every branch inside here ends up providing a value for outer color, or returns, or panics. So, okay, sorry for the long explanation. So this is, we also have optionals. So with this, like etnext can return a value or nothing in case it doesn't find another space anymore. Here I'm asserting that it needs to succeed, and the question mark basically causes a panic if this is null. So I have outer color for real now. The next is and I think I understand maybe what someone was saying earlier. Okay, so we have the outer color, and then we have bags contain, and then we have a list of rules. We have a list of rules. So we need to skip 2 words. We know that much. So let's skip 2 words. Skip bag. No, this is actually always plural. So we skip bags contain. Oops. What's wrong? Oh, I'm missing a semicolon here. Okay, so we skip bags contain. We're going to include bags contain. And then we can have no other bags, number, canonical bag, or like a list. So I guess we need to take the next token and then see if it equals no. Then we know we are done with the line. So how do we call this next token? Maybe let's call it maybe rule. Const maybe rule equals it.next. And we know that it has to be there. So at this point, if mem std.mem.equals, this is this mem.equal is for testing equality between slices, and slices are like fat pointers. So if I had an array in hand, I would be able to do just equals equals, because arrays are values that you can like equate directly. But I don't know what I'm getting. I'm getting basically a pointer plus a length into the original string, and I don't know if like even like I can't put an array there because I don't know what the type is. I could probably, well, now that I think about it, I could probably force this to be. I would probably force this to be an array. Where can I check the problem description? Yeah, good question. It's here, but I don't think it's really public. Maybe I'm wrong. Maybe you can actually see that. Let me see. So I'll copy the link and paste it in chat. You tell me if it's okay or not. Like if you can see this or not. And of course can I paste like this? Sorry. Control C. Well, you tell me how it works. If it doesn't allow you to see this and you need to log in, then or like you need to solve up to here, then I can't really help. But let me know how it goes. So oh, it works. Nice. So maybe I can force this to for it to be always an array of 2 elements. You know what? Let's do this. It's a bit of a cheat. Can I? No, it won't. No, it won't always work. Like, it's a bit of an unsafe operation, and I would have to do a bunch of ugly stuff to get there. Not too much, but let's keep it simple for the stream. So we are equating 2 arrays of U8, 2 slices of U8s. One is maybe rule, and the other one is no. So if we found no, you know we are done. So if they're equal, no rules here. Oh, also interesting. Oh, that's an interesting thing. For each rule. Yeah, no, that's right. Hey guys, hey Benjamin. Hello. So there are no rules here. So this means that if there are no rules here, what I'm gonna do is I'm gonna put in my overall hash map that contains rules. I'm gonna do rules dot. I think it's put, but I don't remember for sure, and I'm gonna double check just to make sure. So hash map. Get or put. We have like just put. Let's get. get, remove, put assume capacity, put no clobber, put. Okay. So rules.put. I'm gonna put for key outer color. So that's my key. What am I going to put? Oh, I need to. You know what? I'm gonna inline the struct itself. So I'm gonna put the struct itself into the map instead of a pointer, because if I put a pointer in the map, then I need to allocate it. But whatever, it's a small struct, so I might as well just do this. So I'm gonna put there a bag rule, and in there, and actually in Zig I can also do this. Like we have anonymous structs that always coerce to the right type, so I can just do dot and then the graph parentheses and the curly braces there. And since we know that this second argument, like the only thing that you can put inside a string hash map that has values of type bag rule is a bag rule, Zig will automatically try to coerce this to a bag rule, and it kind of works. But in any case, well, for clarity, you know what? If there's new people, let's just put bag rule there. So what do we put inside our bag rule? We have color that needs to be set to outer color. So the information is available in two different places, but I want it like this, so it's easier. What red dot? Yeah, it's a bit crappy, the red dot in the stream, I guess. As I was saying, the outer color is like in two different places, but I kind of want that because the outer one allows me to navigate the graph, while the inner one, I guess, allows me to get information about this node even if I don't know where I am in the graph. I don't know. We'll see how this goes. The problem here, now that I'm noticing though, is that if I put the information this way, I'm not going to know. So here's the problem. Let me see if I can draw. So the problem with this setup is that I have this node here, which is, I don't know, blue. And then I have, it connects to red. And then it connects to green. And then it connects to, I don't know, green GR. And then I have GL, which is my gold. Or maybe I should do like G. Can I undo, please? Does this website allow undoing? Oh, using this. Okay. GO. But then the question is, I want to know what's above gold. Yeah, because I don't know. Like, even if I put it this way, I will need to navigate everything upwards up until the surface. And my thing, as it's structured this at the moment, everything is nested and there is no pointer to go up to the parent. So maybe I should put a parent node so that I can find. Okay, I'm starting to understand how things are. I think I need a parent node is not enough though. I need to find everything that relates to this. Everything that relates to this. Oh, I'm starting to think of maybe like optimized ways of doing this. What about flipping the graph? Yeah, there's one. There's also the fact that I only care about gold bags. Like because of the question tells you to only care about gold bags. You don't care about any other gold bags. So it kind of makes me think, what if I what if I only, well, I need to store information about other bags because they can indirectly connect to a yellow bag. But it kind of makes me tempted to say, yeah, so the idea of flipping the graph, so sorry, here's what I was thinking. The idea of flipping the graph, it almost makes me think I should maybe build the graph directly outside in. So I put these, I search for these in the outer layer, and then I put this inside all of them. So like this first line says, red bags contain 1 white bag and 2 yellow bags. So I have, okay, in Safari, this is not cool. I have red that contains white and yellow, and then contains yellow. Maybe what I want is I want to write white and yellow at the top layer, and for each, and make both point to red. And then what I do is I get, and the same is going to be for other things, and there's going to be gold, which points to a bunch of things. And what I want to do is count the nodes downstream from gold. Yeah, I think that's what I need to do. So maybe I don't even need hash maps. Or maybe I need one at the top level, but then I don't anymore. So contains becomes then just a list of pointers to bag rule. Or even better, let me think about it. Yeah, Google, don't forget to let us data mine you. What do you mean by that? So maybe, yeah, this is the best. At the top level, we keep a named list of these things. What I need to make sure, though, to do is that every one of those must also appear in the hash map at the top level. So I think we only need a hash map at the top level. And then for each of those, do I even need a pointer to the bag rule itself? No, I think I need just a list of slices. I need, well, a slice of slices. So these should probably be a list. So I think it std.list. That I can append to it. Actually, this probably has to be array list or something. I don't remember. So each has an array list of pointers. Sorry, an array list of names of the bag that they contain. And then every single time I go back at top. And at the end, I'll just need to make sure that I don't end up following forever loops. Oh, a little paint website. Oh yeah. Yeah. Okay. Yeah, I think it took me a while, but I think I finally got the final structure. Yeah, that kind of has to be it. So we have the outer color. We don't do anything. We skip bags contain. So let's see. There are no rules. So what do we do if there are no rules? All I want to do is put in outer color this bag rule, yes, and contains has to be an empty array list. So I think this is useful maybe also to save as a type. Const color list. I could reuse it, but I think it's easier to just reuse it like this. So here's my color list, and here contains is a color list, and I think we need to give it the allocator. And I just realized that this also needs to be arena. So let's see how this looks in general. So what you don't like about this here? Also, I think put might fail. So let's see. This semicolon, it doesn't like it. Why? Yeah, that's bag rule. Yes, these are the contents of bag rule. This is the if for loop main. What am I missing? I'm missing a parenthesis somewhere. Oh yeah, yeah, the if. Okay, and now I think here I need the semicolon. Okay, now everything works again. So I put a new color list. Color list.init, sorry. But let's double check if we have the right data structure. So std, I was trying to import array list from here. There we go. Array list, which is defined inside array list. There we go. Init and text an allocator. Okay, so we created one rule that points to nothing, an empty array list. And that's fine. That's correct. Now, what if it was already there? So we now have to, you know what? I'm going to duplicate this. So I can keep one page to the documentation of array list and the other one in hash. I have to think of the case where that value was already there. And with this, we just overrode it, but we don't want to override values that are already present. So we need a merging strategy, which in this case is we don't do anything because there's nothing for us to merge. And I guess it would be get or put. So if the key exists, this function cannot fail. If there is an existing item with key, then the result entry pointer points to it and found existing is true. Oh, because get of put result. Where is it? Get of put result. Where is it defined? Where is it defined? It's unmanaged or get put result. Oh no, it's defined some. Okay, it's defining here. So it gives you an entry, which can either be the old entry or your new entry, and then it tells you whether it found it or not. Okay. Okay, I think we can do get or put. Oh, and there's also get or put value, which basically says if you... I'm already providing the value. There's also put no clobber. Where is it? Put no clobber inserts a key value pair into the hash map, asserting that no previous entry of the same key is already present. So I'm guessing this fails if it was already present, but we don't want to fail. So we want get or put, I guess. So we want to do get or put. Get or put the outer color. And what were the other arguments? Oh, we just pass in the key. Okay. We have to try it because it can fail. But the assumption is that it doesn't fail. Like these failures are real failures. We want to return immediately. It's about memory allocation. So var press equals, and then if press dot. So if it was not found, was it found? The exact one, like the exact field found existing. Okay, found existing. So if you haven't found one existing, we just set it to something. So we need to initialize it, which was what we were doing before, I guess. Press dot color equals outer color, and rest dot contains equals a new array list std dot no is color list dot init ampersand arena dot allocator. Okay, so this is the case where we only have this. So just to make it present. So I think this should be, we know that we are at the end of a line. Now let's do these other things which are more interesting. So how do we do? I guess we have to. It's not. So we got one token, and basically everything is aligned kind of like this. So we got this token here, like can I do it? Did it work? Micro, please. Is this it? Okay, I don't know how to do it, but so it's just, we have this token here. We just notice that it's not equal to no, so it has to be a number. So we need to find, I guess, we need to parse the number. We have a number. If we have a number, we need to parse it. So const num equals std.parse or std.format fmt parse int. We are parsing like a usize. It's an unsigned number, like could be u32, whatever. I'm deciding the size. It just has to be big enough for this. Like probably a u16 would be already enough. So as I was saying, oops. Yeah, we pass it maybe a rule, and the base is base 10. So now we have a number. Oh, and we need to try this. This has to succeed. Try basically says, try the return value of this thing is a error union, and you need to inspect error unions. So try basically says, okay, if it's an error union, we immediately return that error. So I get the number. Like for now, I don't care about numbers, but you know what? We might want to make space for those, because my guess is that like these exercises usually have a part 1 and part 2. Sorry, this exercise, and I'm guessing part 2 is gonna require us to care about numbers. So where would the number go? I guess it would be here. Instead of being just a list of colors, it would have to be a list of color and number. So let's make this immediately correct. So instead of being an array list of these, an array list of strings, basically, let's make it an array list of number and color name. So const, I don't know, quantity and color struct that contains a quantity, which is a usize, and color, which is the usual string. And we can use it. We can use it here. Quantity and color. Okay. So this means also here, oh, it's nice because here it's empty. We haven't done anything. So now we have a number, and then we're gonna have a color, and then we're either gonna have, like we're gonna have a color. So I guess we do it again, what we did earlier. So what we did here for outer color, we do it also inside. Or the inner color, I guess. So we skip one space, grab the second, but now we can't start from 0. We can't start from 0 anymore. We need to start from the end of the number plus 1, which is basically length. So we start from maybe... Oh, come on. Maybe rule dot len. Because, yeah, we skip one token to the next space, then we get to this space, and then we want to get from this space, not included, to here. And we already have the end index of this. Oh, it's not, wait, it's not len. It's the last one. Oh, man. Wait. It's not len. That's annoying. That's annoying. How do we do this? I think tokenize might not be what we need. Let me think about it. Because I was able to do this because I started from 0. That's easy. But here, I don't know where I'm starting from. Okay, I get this token. Or the alternative, you know what could be? I get 2 slices and then I glue them together. I mean, I know that these slices are from the same string and they're like subsequent. So I could make a new slice that starts from... Oh, okay. I have to do some unsafe things, I guess, to get there. So let me think about it. So to start from maybe a rule, I want to start from the end of maybe a rule. How do I do this? It would have to be... You know what? I probably should keep a cursor variable. Okay, I could mess around with pointers, but probably the cleanest way is I keep a counter of where I am in the line, and I keep increasing that, and I use it as a base. And that's probably the best way of doing this. So here... Yeah, for example, here I skip bags and contain, but I need to increase that counter. Okay, so that's a good thing to do. We do this, and let's make a function. Function skip, and skip takes in the iterator, and I can cheat because I can say that it is any type. I don't know what the type of it is. Like, I mean, it has a type. It's just a bit complicated. But so we take an iterator, which can be of any type, and then we turn a usize. And what we do is we do const next equals it.next dot question mark, and then we return next dot length. Next dot length. Return the length of next. So now here, every time we skip, we do this, like var counter equals cursor equals 0. We start at 0. Then every time we do something, looks like you're trying to copy to the pasteboard, but mouse reporting. What? I have no idea. Cursor plus equals deep IT. Okay, so this increases the cursor. And let me think about it. Oh, here I'm doing IT next. Okay. I need to do cursor plus equals last.len. And here I want to do the same. I want to do the same twice. And I have maybe a rule. Cursor plus equals rule.len. Okay. So now cursor is at the end of maybe rule. Now let me think about it. Ooh. Okay, now we are at the end of maybe rule. And now we start needing the cursor. So we skip. Oh, you know what the problem is? Oh man. Oof, so many little problems that start piling up. So many little problems. Okay, you know what? This is annoying, but I'm gonna do a little bit of refactoring. This cursor idea is annoying because every single time I split, I'm losing I'm losing the space, and I would need to factor in the space. So here's the thing: for the internal thing, I'm not gonna use tokenize. I'm gonna use like find pause, something like this. This is much, much more sustainable. I need to use the cursor more explicitly. There is no way of keeping stuff like sane in there without using the cursor. So in mem, I think we have, we were looking at it before, we have index of stuff. Index of scalar, and I'm gonna do index of scalar of the space over and over. And that's just how it is. So, yes, cursor starts at 0. And then we do cursor plus equals, we're saying index of scalar. So line std.mem.index of scalar. So u8 slice. Oh, why am I up there? u8 line, and the scalar is space, right? Yeah. So this is the cursor. So we skip the first element. So this is where this +1 is start. And then this is end. And it's the same operation. But now these are numbers. So I'm gonna do line from, well, I guess 0, sorry, this is not start. This is like first. Okay. And instead of line, this has to be line from first. Moving forward. So this gives me the second space, and is line from 0 until and -1, I guess, because this is the index of, well, no, this is the index of the space, so it's not included in the upper count, so this is fine. Okay. And before I return, cursor is at end. So here cursor ends on top of the second space. Okay, so it's taking me a while, but finally I'm solving this problem. Now I need to increase the cursor basically twice. So I'm gonna do it like this. I start from cursor. Now let me think about it. Do I need to increase the cursor? Yes, I think every time I increase the cursor, I'm gonna do +1 so that it starts from the character right after the space. Otherwise, it's gonna find the space immediately in position 0 and everything's gonna be bugged. So we skip that. We do it twice. We don't need this anymore. We don't even need this anymore. I mean, it's a one-liner, so it doesn't matter. So then we do it again, and this makes Let's call this second. So now this is, if I search for the third space after bags contain, then it's gonna give me this space. Okay, so cursor again. But in this case, this is gonna be needed to make maybe rule. And maybe rule is gonna be line from cursor. Let me think about it. Do I want to do the +1? I think I should do the +1 every single time. Yeah. Yep. Okay. So maybe. So here how it is. We skip the 2 words. We enter the space here. We move to the next character. Perfect. Perfect. We move to the next character. We search the next space again, which increases the cursor. But now, oh, I need cursor before. Okay. Maybe rule start equals cursor here, I guess, and maybe rule ends up being maybe rule start. Dot cursor. No, +1 though in this case. Oh man, these +1s are killing me. So at the end of the day, you really can't get away from all the +1s. That's so disappointing. That's so disappointing. Okay, so maybe rule ends up being this thing, or you know what? Let's call this maybe rule end starts here, and then we do maybe rule end, and cursor is also. Do I need to do +1? No, because these are indexes. Oh wait, no pluses. It's just setting. Yeah. What is this font? It's Anonymous Pro. You can find it on Google Fonts, and like just Google it, you'll find it very easily. So maybe rule starts is my current cursor. Yes, maybe rule end is from maybe rule starts moving forward. This is maybe rule end, which allows me to capture maybe rule, and then cursor can be is the end of maybe rule +1, which gives me the space position, right? No, end was already the space position, which gives me the first character after the space. So, which is kind of what I want. Which is nice. And also this seems a good candidate for becoming a block, because this is what we want to use to compute maybe rule. So break LK with this. But these two things don't need to survive, and this can be const. This can be const. So my colon. Oh, but I need maybe rule and okay, so this also needs to go in there, I guess in here. Okay. Oof. So we have maybe a rule equated to no blah blah blah. We parse it as a number, and then we need outer color. And for no, it's not outer color anymore, it's something else. But let's copy this, I guess. Finally done with the refactoring. So this is gonna be rule color. Or like inner color, I guess. So inner color is let me think about it. We have cursor that is pointing at the first character after this. So it's pointing here. So we can use basically the same syntax here, except that we start line is line cursor, and this gives us first. Then we find the next space, yes, which gives us the second. And we go from first to second. Wait, is it first? No, it's not first. Const first equals cursor. We need to save the cursor before doing anything. These can be thrown away because we just keep the first space. We don't care about it. Then yes, we start from, wait, can we start from first? No. Okay, I see. Okay, let's call it start const first end, so that it's clear that this is why I can't. Sorry, no. Start. So the reason why I need first end is for this, yeah, the next step. Okay, so now this is more clear. Since I don't have 0 as a fixed point, in the first one I had 0, which is always 0, and that's fine. But here I can't. Here I really can't. Yeah, and I also need to increase cursor. Okay, so we have the inner color. And after the inner color, I guess we need to find either a space or a dot. Well, we can check the next word. If the next word is bags, then we are done. If it's if it's bag dot, no, because it could be bags dot. Singular or plural doesn't matter. It's singular or plural is related to the number. Ooh, this grammar, holy shit. Okay, we definitely had a jump in complexity today. So inner color, you know what? Let's start by printing what we've had until now. Let's just make sure that what we got until now is correct. So let's do print outer inner new line outer color inner color, and let's do also n. So also let's catch all the compile errors. So expected function found type. Oh, how do we make an arena locator? I don't know. Is in heap, right? Arena locator is a struct. Oh, because it's arena locator.init. That's why. Okay. Expected function found type. Don't tell me. It's another init that I'm forgetting. Unable to find bags day 7 txt. Are you sure? Source bags day 7 txt. Oh, it's looking in source. Oh, thank you very much. You are absolutely right. That was so dumb of me. Wait, is this still complaining? Continue. Unable to find AOC template source bags day7.txt. Okay, so this needs to be checked anyway. Reference here, reference here. Okay, so this seems to be the only error that it's complaining about. Interesting. PWD. So maybe I never saved it. Could that be it? Maybe I just never saved the file. Yep. Okay, consider do not support field access. I think. Oh, I keep doing this. I keep doing for instead of while when I'm packing optionals. I don't know why. Variable type complete must be console comp time, right? I forgot to specify the type of this, use size. Invalid operands to binary expression, use size comp time int. Oh, right, these are all optionals. Oh, okay. Dot question mark. Dot question mark. So we know what the structure is. So I'm doing a bunch of dot question marks because I'm assuming that everything is gonna be there, and if it's not there, like if my assumption is wrong, it means that I messed something up, and I'm fine with a panic. Like I don't need to be resilient against like unexpected input in this case. No member named color instruct get or put result. You're right because it's res dot data entry, I believe. Entry dot color. Is this it? Okay, I need to check this. Hash map. Get or put. Yeah, get or put result. Wait, it is entry. It's either found existing or entry. So if res found existing, entry. Oh, I see entry dot value. Okay. Let's see. Oh, and I'm missing some dot 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 thingies. Cursor dot dot. I think I did it somewhere else too. Cursor dot dot. Cursor dot dot. Was this really the only place? Maybe. Unclarified identifier n. Yes, n is actually num. Okay, interesting. We got an index out of bounds. Funny thing, we don't know where it is. So here's what I can do. I can print things as I go, which is probably better. Outer color. So here we have the outer color. Here we have the maybe rule. Uh, and here we can do num, maybe. But we're not gonna reach here since there's the out of bound error. But hey, at least we can set it up. So what did it print? Panic during a panic, aborting, press to continue. Okay, there we go. Outer color LIG, index out of bounds. Okay, so this is not going well. Why is outer color this messed up? Let's find out. I have index of scalar space LIG. LIG. Wait, how can this really be? Okay, I think I need a terminal. So do this, split pane vertically. Or you know what I could do? Yeah, let's not split the pane vertically. Let's split it horizontally. And I put this here. Okay. 907. Why is this LIG? Oh, sorry. Why is this LIG? Why is second starting from the end of first? Plus one. Yes. Find second. Line goes from 0 to second. Then we skip twice, but this is already wrong. Because we see this that why is it LIG? And then immediately index out of bounds, so we don't even reach here. Index of scalar is not behaving as expected. Print first. Am I getting bamboozled by it? What's going on? First is 6. That's correct. 0, 1, 2, 3, 4, 5. Wait. Semicolon is an index in line first, not line, I think. Oh, you're right. You're right. I'm an idiot. I'm such an idiot. Yeah, you're absolutely right. I tried to escape from this problem of sub-slicing, and then I ended up recreating it anyway. I'm a complete moron, and there is the answer somewhere where it's pause, where you can pass in the start index. God damn it. Yes, thank you. I tried to evade this problem, but since I'm stupid, I could not make it work. So I need to use index of scalar pause and pass in the start index. Index of scalar pause. We start from 0. Index of scalar pause. We start from first. Thank you. Yeah, I don't know why I'm so stupid. Okay, so we can cut this away, save. Index of scalar pause. Line cursor. This is our position. Okay, let's see. I should have at least fixed the first part now. Expected 3 arguments, found 4. Oh, index of scalar pos doesn't need a type. What? Key type slice start index value. Type slice start index value. Oh, fourth function isn't a pos. 1, 2, 3, 4. Oh, you're right. I updated it, but I forgot to put the pos name. Okay, save. Thank you. Uh-huh. Yeah, outer color, right red. Okay. Oof. So we are back to kind of functioning. I'm an idiot. Like this slice thing always bites me in the ass, and I always I tried to avoid it. The other two, there were a couple of days where this was a thing, and in both cases I got fooled by it, by this problem. So I think that we can optimistically remove these prints here and just make sure we do everything right. Scalar pause. Oops. Wait, what? Why did alt? Why did alt change up? Curious. Okay, this is all should be working as expected. So now we can print here. We can go back to printing everything. So what was it? You know what? Let's do it like this. So we have outer color num, inner color, error invalid character. Okay, interesting. So we got the 1, 2, 3, 4 lines partially but correctly. And then with invalid character, I'm guessing it's a no line or something. Oh, no, these are the edits that I made. I added some extra spaces. Bad me. Bad me. Okay. We got further. Go to vibrant plum. And then we failed at the no. Do I not have a do I not have a return here? I should have a return, right? Because if there are no rules, we find that out and then we just continue. Yep, and we just continue. So then we have a number. We do this stuff. So this is all okay. Here we can remove this print. Oh, so finally we are correct. Have the inner color. Then we have to understand when we need to continue or not. So I think we should search for the comma and loop there. Oh, actually, wait, we need to slot this new thing in. So we found out the number, we found out the inner color. We need to kind of do this. So we try to get or put inner color, and we say, if it's not found existing, we want to set color and contains to an empty list, I guess, yes. But in any case, even if whether it's not found or whether it exists or not, we don't care. What we care is that contains. We need to, I guess, I'm assuming we have a push thing. We need to push, what is it? A quantity and color struct. We need to push quantity equals num and color equals outer color. Oh, and here it's not outer color, but it's inner color. Okay. So we want to say that num points to outer color. Okay, this should be correct, assuming push really exists on array lists. So let's go find that out. Array list. Thank you. Array list aligned. Init capacity, the init. Do this, do that. I don't care. I don't care. Oh, there's append. A push too, just out of curiosity. Pop. There's pop, but there's no push. Okay, we're gonna just append. It's fine. So append self item t. Very simple. Okay. Okay, so now we need to understand whether we are done with the line or whether we need to continue. So what we need to do now is from where the cursor is now, which is after the end of the inner color, we need to find a comma. If we find a comma, there's some work to do. If we don't find a comma, then we are done with the line. So it's something like this. If, oh, why is this paste mess up? Copy. So if color index of false line starting is cursor, and we are not searching for a space anymore, but we are searching for a comma. If we find a comma, we're searching for a cursor, and this is an optional value, right? So if we can unpack it, which means that we did find a comma somewhere in the remaining part of the line of the string, then what we do is we set cursor to that. We set cursor to the position of the comma. Should I do +1? I should do +2, comma +2, because there's a space afterwards. And we continue, but we continue what? We continue this. This has to be a while loop in on itself. So while true, I guess. Oh, I love while trues. They never go wrong. We continue because we need to do another round of everything, and we don't know how many those are there. So this is why while true. If we don't find the comma, it means that we are at the last chunk. And if we are at the last chunk, then we're done. And we can break. This break is going to break us from the inner while. We can also have labels to be precise about what we are breaking from at blah blah. But this should be fine. Well, you know what? Let's call it rules, or like constraints. And we can say we continue constraints. I think it's colon constraints, and we break from constraints. So there's no ambiguity there. And this should basically do everything. Now, what this should do now is, I guess once we are done with this, as a starting point, I'm gonna print what's inside rules. I'm gonna print what's inside rules for golden bag to see the direct connections, but that's not enough because we need then to navigate all the indirect connections. So yeah, let's do that. Let's print that. So what was it? Rules dot, well, const goldbag is rules dot get goldbag, I believe. Is this it? Shiny gold. I'm dumb. I forgot also the naming convention. Shiny gold. And then also I think this should it be a try or what? GitHub, so I can have one always on the hash map. Get or put, get, okay, returns an option. So rules of get dot question mark, and then we print gold bag. Print direct connections, and then for gold bag dot contains dot what? I think we need an iterator. How do we grab an iterator? Can I do to own slice? The color owns the return memory. Array list becomes empty. No, I want to slice then. There are like two slice, but you know what? It doesn't matter anymore. We're at the end of the program. Who cares? Give me an own slice. E, and then we print num color new line c dot quantity c dot color. Okay. Contains dot items. Oh, dot items is, thank you. Is it like a slice always present? Is it like a property? Yeah, it's okay. Type slice with an uppercase S. Hey Diego, thank you for the follow. What is this uppercase S slice? Where is it defined? Self slice. Oh, there we go. Okay, yeah, alignment stuff. Okay, cool. Thank you very much. I'm just cosmic. So we should have it like the basic starting point almost. Error is ignored. Append can fail. So let's try to append. Num1 bright white, num2 muted yellow. Bright white, yes, and muted yellow. Yes, these are the two direct rules. Nice. So what's the next step? The next step is probably these rules don't have loops. Maybe. But we need to make sure that we don't revisit nodes that we already visited. So once we get the gold bag, we need to create a yeah, it's a dangerous assumption to make. I agree. I 100% agree. So one thing that we can do, well, you know what? At the end of the day, it's not the end of the world for this specific case, because I'm going to run the program. Like if we go down to the nitty gritty, I'm going to run the program myself. And if it's a loop, it's going to loop forever. It's never going to stop. If there is no loop, then it's going to stop basically immediately. The input is not that big. So since I am the observer here, my point is, the good part of it is that it's not going to give me wrong numbers. It's either going to loop forever or not. So if my assumption is wrong, I'm gonna catch it, I think, reliably. It's not gonna like inflate my number for no reason. Which kind of makes me want to skip this part, to be honest. You know what? Let's try to skip this part. Yeah, that's the spirit. Yeah, I mean, so if you think about it, that's an interesting point in general. Like, what should we care about when we are writing this program? Like, if you want to be, if you want to take this as an exercise, and trying to make things nice, then we already compromise a lot in the parsing system. Like the parsing system here, it's madness. Like this is not good parsing uh, by any stretch of the imagination. So we are not robust for the input at all. And we should probably use a parser combinator. Like this stuff is really parser combinator territory. As for this, I think we should worry if the thing can give us wrong answers and we won't be able to recognize those in case an assumption is wrong. But in this case, it's kind of clear cut. Either there are loops or there are no loops. So fuck it. Let's go the quick route. So we have the direct relations here, and we need to start counting. So how do we count? AF tab 25. Thank you for the follow. What do you mean this isn't parsing? You implemented Mega Plus Plus. I don't know. I wouldn't call it plus plus. I think it's Mega minus minus. Like this is kind of sad. I'm so ashamed of the index color posting too. Like I did a refactoring and then I was still like messing around with the same type of problem, which is keeping track of a freaking cursor in my line. Anyway, so we need a counter. For each item, we do counter plus equals 1. We could do better, right? We could immediately add items, but whatever. We do 1. And then do we recurse? It's not a problem recursing, right? Let's hope it's not, because otherwise I'm gonna need to also try to solve that problem too. So counter plus 1. And for each item, then what I want to do, I should put this in a function, right? So that we can call it recursively. So function count dependencies nodes. Let's call it count nodes. Count nodes. You need to give it, I guess, rules. Also, look at me not caring about types anymore. An any type, then we give it a node, which you can guess it's an any type. Should it be an any type? No, in this case it's just a string. I mean, I could put it any type, but whatever. We know it's a string. So let's call it color. Give me rules. You give me the color that we are trying to inspect, and then we give me a what do you give me? Nothing actually, because we just return. We return a usize, and then count node says does basically yeah, does this. Finds the node from color. Here we say color shiny gold. So we get the node like this. Why is micro keeps going down? Please, micro, for the love of God. This is like set trailing new linter. Oh God, micro. You're disappointing me so much. Okay, you know what we're gonna do? Damn it, micro. Oh, right. Oh no, you know what? It's not micro. Maybe it's the FMT. Like the combination of the two evil programs. Okay, so we get the node. And then what we want to return is, well, I think we need an accumulator. So var count to size equals 0 for node dot what was the thing, contains dot items child count plus equals count nodes count nodes of, well, passing rules, we pass in child dot color, and then finally we return node dot contains items plus count. And that's it. Let's hope we don't have trouble with depth with our stack. Print. Well, we don't have problems with this input, that's for sure. Let's hope we don't have problems with the other either. Count, new line, count, nodes, and we pass in rules, I guess, and color. Is this going to work? Oops. Oh, what did it do? Okay, save. Actually, programming errors for sure. Yes, incompatible times. Oh yeah, is items.len. Attempt to use a null value. Ooh. Attempt to use a null value. Is this here? Okay, let's not print anything. So yeah, it's there. Random typos are really interesting somehow. Yeah. So why is rules get color sometimes? It doesn't make sense, or does it? I think I'm missing a case. Oh, wait a second. Oh, you know what? Wait a second. No. Okay, this is right. I'm increasing the cursor. So, okay, what does it mean that this is null? This is null means that we have a color mentioned in the dependencies downstream from another color, but we don't have it at the top level. And it's true that when we find a color, you know what? Or else return 0. Is this the cure? Count 4. That's a bit too low. Or is it? No, I think it was more than 4. With that, we probably have a bug. Oh no. So in this example, the number is 4. Let's give it a go. Puzzle input, copy. This is gonna blow my stack. This has the power of blowing my stack, I fear. What? What? Uh, YOLO. 26. I expected much worse. Could it really be just 26? I mean, it's just a matter of counting. Wait, am I counting? Can I be counting duplicates somehow? Give me a second because I might be counting duplicates. Mm. Yeah, there are good chances I'm counting duplicates. You know why? Here's one thing that I'm doing wrong. This is, I made this an array list of strings, but is it possible for this to have duplicates somewhere? Let me think about it. Is it possible for this to have duplicates somewhere? Could it be that for a given outer color, could it be there are two different dark blue, dark plume, dull green, dull beige? Like another interesting question is, are these all unique up here? It kind of seems like so. Do we know for sure? What if light green, for example, there's another one light green somewhere up here that we are defining rules for? Okay, you know what? Instead of overthinking this, I got 26. Fine. Let's try 26. That's not the right answer. Okay, so we got a bug. That's for sure. They're wearing my input. Okay, yeah. So if that's the case, then, which is what I was fearing, it means that we cannot just append here willy-nilly. Either we make this a hash map and we should maybe make this a hash map too, which was kind of the original plan, almost. Oh, they were unique in your case. Okay, I see. They were unique in your case. So that's one possibility. The other possibility is that I made some mistake here. So I start from. Could it be that it's +1? That's not the right answer. Make sure you're using the full input data. There are also some general tips in the about page, or you can ask this in the subreddit. This one, trying again. Okay, so could it be that I have like a +1, -1 problem of this kind? Like, why is this 4? This is 4 because it's only counting other colors. Like, it's not counting shiny gold, right? Because we want how many bag colors can eventually contain at least one shiny gold bag. Oh, you know what I might have? Could it be that I have rules, something that say a shiny gold bag can be contained inside a shiny gold bag, but in that case, I don't want to count that. So here's what I'm gonna do. I want to say, like, if any of the childs is a shiny gold bag, I don't want to count it. So how do we do this? If std.mem.equal child.color, if this is shiny gold, there were no self-references like that in my input either. I don't even think there were cyclic dependencies. I think you're right, because if there was shiny gold mentioned anywhere, I would have an infinite loop. Because if shiny gold was one of any there, I would then infinite loop. Yeah. That's a good point. So that's not the problem either. Interesting. Then we have some other kind of problem. Are we parsing this correctly? So here's what I can do. Var loops. We have loops counter, and every time we continue, do loops plus equals 1, and at the end we print rules in line yeah. Okay, I'm starting to smell the problem here. I'm starting to smell the problem here. Did you try to run your coding example rules? Yeah, I did. Yeah, I just did it. I think we have a problem with this. Why is this never triggering? Like, this is kind of crazy, right? It means that we are missing a lot of constraints, which kind of explains the low number. That's weird, because this was working before. They mess up the file somehow by pasting wrong shit in it. Um, yeah, it all says 0, which means that it only grabs the first one. The condition here never becomes true. Wait, I'm an idiot. Okay, so loops has to be, oh god. I just cut it and I paste it now. Micro, please. Thank you. So loops has to stay outside, and before we break, we set loops to 0, I guess. Okay. That seems so much better. So you know what I'm gonna do? I'm gonna go here, do this, pipe more. Okay, this is not great. Pipe more is not giving me really what I want. Thank you very much, pipe more. Because it's pipe. How do I redirect stdr? 2 ampersand 1 ampersand 2 1. I don't remember. Is this it? No. No, that's not it either. Oh man. Is there not a more air? It would be so much nice. Oh, thank you too. Okay, I put the ampersand everywhere except where I needed to go. Thank you. So rules in line. So first line, we have 2 rules. Let's go check this out. Oh no, what did I do? Two, well, two extra rules, I guess. The count doesn't count only how many times it finds a comma. So 2001, yes. 33, yes, three commas. Three commas. Okay, so we are not parsing this wrong. We are parsing this correctly. I mean, this is like just sample, but I think it's already enough to kind of prove that, okay, this is happening. This is happening as expected. I think the problem is um, how we are going through the graph. Could it be? Here's what I can do. I can do this. Print. Shiny gold, dotted plum, mirrored salmon, shiny gold, bright coral, vibrant tan, vibrant black, bright coral, bright coral. We can, I think we can check like a couple of these things. So let me put this in the terminal. So shiny gold points to dotted plum. So dotted plum. So we have shiny gold bags in here. That's correct. From shiny gold, we go to dotted plum. From dotted plum, we go to mirrored salmon. Yeah, but dotted plum brings us to mirrored salmon. From mirrored salmon, we don't go anywhere. So how do we know how to go to mirrored salmon? We need to find other mentions of mirrored salmon, because anything that can contain a mirrored salmon can also contain a golden bag. So any other mention should be fine. Find, okay, mirrored salmon. What is it? Control N. Right? Sorry, Alt G. Control G. No, ask. Alt G. Okay, you know what? Just since now things are getting serious, just to make sure I don't mess this stuff up, here's what I'm gonna do. I'm gonna bring up the big guns. Sublime source bags. Thank you. Okay, Sublime. I think we can do it like this. Even a bit more. Find. Was it mirrored salmon, right? Okay, there are no other mentions of mirrored salmon. So okay, this is true. I can attest this for real. So this is correct. Mirrored salmon is correct. Out of curiosity also, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay, so count is also correct. What does this mean? What does this mean? So let's assume, what if I made an error pasting stuff in there? No, that's the same answer. Okay. So what might I be missing? You know what? I want the full list of colors. I want to see the full list of, yeah, I want to see the full list of colors. I guess that's something also that I can do that might help. So the file disk has changed. Reload file? No. Um, yeah. Show me afterwards the contents of rules. I don't remember how you iterate rules. It's hash map. There's an iterator. A iterator. So for var it equals rules iterator. This is not a for, this is a while. It.next. What does it give you? The iterator? Const iterator. Yes. Oh my god. Const iterator. Thank you. So yeah, next, and it gives you an entry. Okay, so it's dot key, I guess. Next. Print. I guess I just want, let's put it between brackets. Yeah. New line. X. And maybe before that, print all colors. Oh, you know what? Let's not even run this here. Let's run it here. Oh, did I not do? Oh man. X not key. You seem frustrated. I don't know. I'm. Ooh, okay. Oh no. Ouch. There definitely were mistakes. Oh no. The parsing has failed us. What happened? There's one fairly common condition which causes us to parse things as garbage. Okay, so we clearly found what the source of the error. So how do we stop parsing garbage? Let me see. The garbage, I'm assuming, is, do you think it's after the comma? Because we parse correctly simple stuff, is it because of the comma? Let me think. No, it's not after the comma. Or it could be after the comma if there are two spaces. Is there like two spaces anywhere? Is this a sneaky input? No, there are no double spaces, only single spaces. Okay. Deep down the rabbit hole. I think we're almost there. I think it's just a matter of finding out what moronic bug I put in the parsing code, and then we're good to go. So let's see. What would be nice to know is like 5 striped, 5 dotted. Let's see how many copies of these, like 5, how many things are 5 striped. Okay, there are a few options, but not too many. 5 striped olive bags, 5 striped red bags. Here's a trick. So here's what I can do. I can go here, and after here, I'm grabbing in the inner loop a name for when I'm trying to grab the inner color. Here's what I'm gonna do. I'm gonna have this check where I say if inner color, if the first character is a 5, then I want to know the line number. And to know the line number, I guess, actually, no, I don't need to know the line number. I just need the line. Print plug in line. And this is the line where I messed up. And we return. And I think this should help me. There we go. So this is one of the cases where I parsed this wrong, and it is after the comma. So the 5 is after the comma, which makes me think that there is a bug in this code here. Because I do comma pause +2. Where was cursor updated last in here? At what point would you consider adding tests? When doing this exercise, never. I'm never gonna bend to adding tests. No, I agree. Doing proper software development, you know what? I don't know. I think trying to revert to good practices is just something that is going to make you feel bad, because we already are in undefined design behavior, in undefined design land, right? We already made bad decisions from the start. So trying to course correct to something good is only going to make you feel bad, because you realize you are like in the middle of nowhere where nothing makes sense. So I'm not even going to attempt to gather any sanity in that regard. I'm just going to you know what, kind of interactively debug my application like this, and that's it. But I also think that I think I'm close. I think it's really like a stupid off by one error of something of the sort, and after that I should be good. I hope so. If I had a feeling that everything was wrong, like that there were multiple errors scattered around, I would probably insist in starting from scratch. I was thinking that having known inputs plus known good results would just help debug the logic. Yeah, okay, I see that. Well, we kind of do have that, right? It's just a matter, we don't have precisely known inputs, but we can go back to what the inputs were. I mean, at the end of the day, the cycle is by line. So if you have a mistake, it's going to be in the context of one line. And for example, here I isolated one of such mistakes. So here there is something wrong with this thing that kind of moves the cursor past the comma. And here's what we can do. Here, instead of returning, this check for inner color can be moved. Let me think about it. can even move it here, I think. Don't tell me. Command V. Okay. So we can even move this check inside here. Let's see if it still works. Yes. So the check in there works. And this allows me also to print the new cursor position. So this is the bug where in which the line was. And here I can say cursor is line from cursor moving forward. And now we can see. Wait, what? Okay, so right, we are at the. Oh man, the number inside the loop. The number is almost inside the loop, but the parsing of wait. Oh, there we go. So we found the problem. Here, I start from constraints from here, where we start by grabbing inner color, not by grabbing maybe rule. So the answer is that this stuff here should just be inside the loop. Even though we know that if we are restarting the loop, this is never gonna happen, which is why I didn't try to add all this stuff inside the while loop. Because I said, I was thinking, well, no, it's not gonna happen again. Yeah, maybe, but I need to regrab that token again. And there we found the problem. Which means that now, let's delete this, save everything. Let's go in the other tab. Let's print everything. And I think, okay, now we can invalid character. Okay, so now we need to find out what happened. Oh, I know what happened. The discontinue, since now we are inside this while loop, discontinue is a continue for the outer loop. Line. So we want to continue line. Okay, so now all the numbers are clean. That was it. That was set as I expected. It dumb mistake on my part. And the answer, the count is 248 now, which seems a bit more in line with what I would expect with an input of that length. Like, you never know for sure because it depends on how the roll are structured, but 248 sounds more plausible. Oh no, that's not the right answer. Okay. Interesting. So we still have bugs, but at least we don't have parsing bugs anymore, which is good. Yes, but lines reference other lines, so they're not completely isolated. Okay, that's a good point. So in that case, that would point to a bug in the way we construct the graph and how we loop through it. Which is, yeah, I agree. That's a reasonable point. I think the other problem is that if you start having tests and you want expected behavior, the problem is, how do you test graph stuff? Like, you need a bunch of tests where you have like a few examples with like direct reference, indirect reference through, I guess, 1 step, 2 steps. It's a lot of work to get the input, the test code right in on itself, and to cover all the cases. I don't know. That said, you know what? How things are going, it seems that I have a bunch of mistakes here still. And I wonder how that could be. Like, these all sound reasonable. So these are all okay. Why is 248 too high? Why is 248 too high? Um, yeah, it's a lot of work. It's something I'd only consider when getting stuck. Yeah, no, I agree. In the context of IOC, yeah, I don't know. I don't feel like I'm stuck. I think I have I think I understand the general scheme. It's just there clearly were a couple of bugs, which one was pretty obvious, right? Like I was parsing things the wrong way. Like this was garbage. And now I don't have this garbage anymore. But this kinda makes me worry because I have less control uh over this second type of bug where I I I tested these a little bit right earlier and it kinda made sense. So this seems fine. Just a bunch of trees. Let me think about it. So what else can I do? Let's assume for a moment that I didn't fail at building the graph. So let's assume that the graph has been built correctly. Actually, let me double check quickly how I build the interesting part of the graph. So we grab the outer color. We try to grab the inner color. If there is an inner color, we try to put the inner color in our data structure. And that creates a node for itself. And it initiates an empty list. Oh yeah, so yeah. And then it puts inside the list the outer color. And this gets repeated for every inner color mentioned in the line. The outer color doesn't change until we break from constraints because we are done. And then we get a new line where we grab another outer color and it then repeats. So it seems that like the parsing is correct, seems correct. It seems that the graph, how it's being built, is correct too. And it doesn't seem like even too hard. Also, why the number is too high? That's interesting. So number too high kind of points to duplicates of some kind, which is interesting. Hey Yatko, thank you for the follow. Wow. This challenge is beating my ass. Going strong, I see. Uh I'm doing a Advent of Code thing. So I don't know if you were here earlier. I see that you just follow. I don't know how long you have been watching, but I'm doing the 7th day AOC, and I think I'm close. Not quite. I have the general strategy down. I was doing the parsing. I found a parsing bug because I'm doing parsing by myself in the most horrendous way possible. But now the count doesn't match, and I'm thinking that since the number was too high, I'm really starting to think that I'm making a mistake here. How do we solve this? Let's assume that really there are duplicates there. Also, let me think about this. So there is another possibility where a bag is never mentioned at the top level. It's only mentioned inside. So like the case is you have blue bags that can contain white bags and white bags that can contain gold bags. No, that doesn't make any sense. Because to say that white bags can contain gold bags, white bags need to be at the top level. Like my wonder was, what if there is like a type of bag that by not being ever mentioned here in the beginning, then it's a bag that cannot like can be a chain, can be a wrapper to my gold bag, but cannot be a top level bag. But I don't think that's a possibility either. Like here we say played tomato bag, but played tomato is gonna be mentioned also at the top level for sure. Okay, played tomato is pretty popular, but then there you go, it's here. So I'm thinking that there might be duplicates of some kind in here. So how do we solve the duplicates thing? The answer is let's do like a set thing. So there's the color, but then give me also a set. And every time we inspect a child, we add to the set. Set.add like child.color. Yeah, that sounds right. Var set equals std dot hash map. Oh no, I want a string hash map. It's a set, so there are values are of type void. And then dot init arena dot allocator. And then it means that this is a put color, and then we need to pass a void value because we don't have values. This is a hash map that's being used as a set because there are no values, only keys. So then this becomes set.iterator. And that prints the uniques, but I also want the count. How do you get the count inside the hash map? I'm assuming it's not count, but yeah, just to make sure. Okay. Okay. Extract the type pointer to SD hash map blah 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 found const hash map const wait void thing hash map. Oh, I know why. Need to pass a pointer to the set. This color highlighting in micro is not exactly the best, huh? Error is ignored. Okay. Try. I frankly followed, but from what I can see, you store a bag, and the array of bags it contains in your hash map. So what you do with shiny gold is you check how many different colors shiny gold contains. Am I right? Kinda. I check that, but I also do that like recursively. So yes, every time I find, so this is my source file, and I want to know how many bags can contain a shiny gold bag, directly or indirectly. So what I do is every time I find a bag definition for each of the bags that it can have inside, since I'm interested in the inverse question, I put in my hash map this color, and I say that and I put inside of there in an array list, I say that these can be contained inside a striped turquoise bag. Then, when I'm checking the answer, and I do this for every line, when I'm checking the answer, I start from shiny gold bag, and then in shiny gold, I find the list of bags that can contain a shiny gold, and I continue this, and I recursively check every child. So for each child, so I start from shiny gold, right? And then I use count nodes. So starting from shiny gold, I get the node that corresponds to the shiny gold bag. And for each of the items that it contains, I do count nodes, which is the same thing recursively. At the end, everything gets summed up to count, and I return. Is this the problem, maybe? Count plus items len? Well, let's say that there were like 3 bags that can contain shiny gold. Then I would have shiny gold that contains 3 children, and each of the children is 0 because the idea is the children are cannot contain by any other bag in this assumption, which would be 0. So this count seems correct. What was the compiling error? Expected due size. Found type info const. Hash map equals string 80 put. Function return type error union error set. Oh, okay. What a weird, complicated way of saying that I need to try this. Invalid operands. Yes, this also needs to be try. Now that everything can fail. Oops. Cannot resolve the inferred error set. Okay. Right, because this is recursive. Any error. Oh man. Save B. Okay, but this lets you check if shiny gold contains something. But is the inverse true, or am I missing something? No, I'm building things upside down in the beginning. Like this file. Okay, I'll get there in a moment. Let me just check this. Okay, count is all colors. Hey, why is it all colors? Where's my uniques? Yeah, I don't even want this. Uniques count 169. Okay, so there are some duplicates in my count. So sorry, let me answer your question, Cosmic. So the idea is this text file says striped turquoise bags can contain gray bags. And somewhere down says gray bags can contain some other bag. And then it says this some other bag can contain a shiny gold bag. Now my question is how many bags can directly or indirectly contain shiny bags? So what I do is I don't build the graph by saying, well, we said stripe turquoise, so I don't have a stripe turquoise node that contains bright gray and bright bronze. I do the inverse. In my graph, I put bright gray bags that contain striped turquoise and bright bronze that contains striped turquoise. So I build it up upside down, like I build the inverse directly in the beginning. Now, what was interesting that I just discovered by running the program is that my count, by counting things, returned 248, but there has to be duplicates, or I'm missing something in the duplication. Sorry, in the way I'm navigating through, because the unique count is 169. So I'm gonna try 169 as an answer. That's the right answer. So I have duplicates. The part that I feared was that there would be duplicates somewhere that I didn't notice. Because of this, I'm guessing that this is what causing duplicates. This is very interesting. So my count here, so this count here is wrong. And it's wrong because there are duplicates. Well, good to know. Let's continue to part 2. Part 2. It's getting pretty expensive to fly these days, not because of ticket prices, but because of the ridiculous number of bags you need to buy. Consider again your shiny gold bag and the rules from the above example. Blah 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 blah. Okay, so now the numbers that, like, the number of bags that you have to have in the previous example didn't matter, but now the number I think is gonna matter. So a single shiny gold bag must contain one dark olive bag, and the 7 bags within it, plus 2 vibrant plum bags. Oh shit. Why is this? Oh no, now it wants the theme built the other way around. And the 11 bags within each of those. This means 32 bags. Of course, the actual rules have a small chance of going several levels deeper than this example. Be sure to count all the bags, even if the nesting becomes topologically impractical. Here's another example. Shiny gold contains 2 red bags. Dark red bags contain 2 dark red orange, blah 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 blah. In this example, a single shiny gold bag must contain 126 other bags. How many individual bags are required inside your single shiny gold bag? That's annoying. That's annoying because this wants the graph built the inverse compared to what we are doing right now. Which kind of makes you want, probably the right approach would have been not to over optimize with whatever we were doing, but to make a generic tree and navigate it upwards. And now we were going to use the same tree, just navigate it downwards. I probably was too creative with my data structure because now I don't have a good way of going the other way around. Unless I add the inverse path, which I never added before. Do I need to change stuff? No, well, I need to change stuff, that's for sure. How much stuff do I need to change? So let's think about it. Here we're grabbing the outer color, and then we are placing it inside the inner color. But what we can do is not do this. we don't put the inner color outside, but we put the outer color outside. And inside, we put the inner color. So now, yeah, generic graph would have been too much work. It's simpler to have another structure storing data the other way around. I don't know. I think I can probably get away by just flipping around what I was doing here. So now, so earlier, let me undo what I just changed. So earlier, I was placing at the top level the inner color, setting the node. So this was the hash map key, right? The node state was here, and then I would append the outer color in its to its children. But now I do the inverse. I put the outer color outside, I set the outer color in the node, and I put the inner color as a children, as a child. And now the number actually makes sense, because earlier I had the number, I would store the number because I suspected it was there for a reason, and it was probably just a good idea to keep it around. But it didn't have any, well, it didn't have any particularly useful meaning. Like, you could still make use of it, but it wasn't particularly useful. Now I think it's better. So now, by just inverting this, I think I'm writing the graph the right way. And now if I start from shiny gold, I know which bags are contained in shiny gold. And I think that this also has the nice property that if outer color is not mentioned multiple times in a row, this is not going to have duplicates anymore. And I think now my graph navigation thing can work. So here's what I'm going to do. Count is not going to be any more count of any... Let me think about it, of any unique stuff. Okay, let's change this thing hash map to usize. Okay, I'm gonna just repurpose the code. I think this should be fine. So what we do is count one thing at a time. So for count here, count it starts from 0. Instead of adding this, what we want to sum is we want to do count plus count has to be child dot quantity plus the quantity of its children. Yes. And then at the end we return count. This should be fixed. Let me think about it very quickly. We try to get the bag. And for each of its children, we take the quantity of that children plus whatever is the quantity of its own children. Oh, but that's not it. That is multiplicative. It's not additive. Like if I have 3 bags of one kind and each contains 2, then it means that I need 6 bags. No. I need more than 6 bags. Oh man, okay. So let's see. Sorry, I wasn't reading the comments. But if you invert, you lose the first part solution, right? Yeah, you know what I was doing the previous days, I was just basically copy pasting these and making part 1 and part 2, and I would just copy paste the function. In this case, I'm editing it because it's been already 3 hours, and I don't know, I'm not publishing these anywhere. It's not good code. I think it's interesting maybe if you want to follow along the experience of coming up with this stuff and why I'm doing things, but like I don't think anybody should do this. Like I don't know if you were here since the beginning, but the right way of doing this is like you immediately go to GitHub and download Mecha. First thing you do is that you get a parser combinator. Then probably you use a decent data structure from the standard library. You don't come up with things yourself, unless you have to, unless you have a good reason. In this case, I don't think I really have a good reason, except that our leaderboard, we have the rule in our leaderboard where you should not use anything outside of the standard library. And I should probably still use more of the standard library than what I'm doing right now. So in any case, if that's the case, I don't like the idea of such edits. I know people who complete for leaderboard to do that in a more chill environment. They would want to lose work. No, yeah, you're absolutely right. Like, if I mess everything up and then I insert bugs here and there, it's gonna be a nightmare. But the thing is, I think that this is enough of an edit inside, and I'm just changing this code at the end to use to navigate the graph. Now I'm having trouble with this stupid equation. Like my brain is almost gone. So we have our gold bag. Can I go somewhere else? So we have our gold bag that contains 3 bags. And then each has to contain 2 of the same kind. Or whatever it is. Let's say so we need 2, 4, 6 bags plus 3. But what if it says, so let's say the idea is, okay, this would be 1, I guess. What if it's 2 of these, one particular bag? So this would need to be 2 times 2, so that's 4, plus 2, 6, plus 2, 8, plus 3, 13. Yes. So you need to multiply by num, but then at the end you need to sum the number of children. So you multiply by the quantity, but then you return the number of children. So node.contains.items.len plus count. Is this really correct? Good question. I don't know. Let's find out. Expected type usize found void. Oh, you're right. In this case, I changed this. So child.quantity. I could keep so this is a double check in case there are duplicates. I commented it for now, but in case the number ends up being too big, I'll uncomment it and go through a set that way. Okay, so 26,871 bags. 26,871 bags. Oh no, that's not the right answer. Do I still have the problem of duplicates? So I think that the choice of using a array list here has cursed me. Like, this has genuinely cursed me. So let's make this a string hash map. Instead of using this string, should I make this a string hash map? Yeah, I think maybe that's a good idea. I think it should be items.len in the return statement. You mean here? For the quantity of the color. But the quantity of the color. Oh, I think you're right. Wait, I think you're right. So let me undo the change. I think you are absolutely right. So we need to multiply this by the quantity. That's correct. But then we need to add also the quantity, like the outer bag itself, or the wrapper bag, I guess. Child.quantity. Yeah, I think you are absolutely right. This was a very dumb idea down here. Yeah, that seems much, much better. That was a very good point. I think I need to wait more to answer though. Oh no, that's the right answer. Thank you. Man, you caught a very dumb mistake. Oof, I was starting to getting tired. I have to admit, like the parsing um, really killed me. This parsing was tedious, error prone. I just wish I could use the parser combinator stuff. This format is evil. Like you have to go through the natural language stuff, style thing ish, quote unquote. It's kind of boring. You have to tokenize over spaces, count the right thing. I made a mistake. It took me like I think most of the time. At the end of the day, like the graph was not a bad idea. Like the way it was structured like this. So changes that I would make, like improvements. Um, it was a problem. I was forced to like kinda build also a set when I was navigating my graph because I was suspecting there were duplicates, and turned out it was true. And why there were duplicates? Because this damn array list doesn't duplicate, and should have used a string hash map also inside. That would have helped me much more. That would have resolved all the duplicate issues that I had. But in the end of the day, I was able to get through that. Like now, in this other version, like the proper version, when we keep the outer color, so the one mentioned at the beginning of the list, we keep it that at the top level. Since each color has only one rule for it, like it's not like the same color is mentioned in multiple lines and like the rules add up. Since that doesn't happen in the input, then this doesn't produce duplicates, which allowed me to use this function correctly to do the counts, except that I needed to get this stupid equation right, and and I didn't manage to do that. So thank you very much, Cosmic. That was really clutch. Um, what can I say about this? Um, at the end of the day, this wasn't that bad. I regret the array list. Should have stayed with the string hash map. I wonder if using a pure normal tree data structure would have helped. Maybe, maybe not. Maybe not. I still kind of suspect things would have gone like I would have need to have care of solving this problem too. So I think hash maps would have been the best possible thing. Okay, you know what I want to do? Let me I solved the thing, so I'm basically done. But before I leave, I want to remove this unique set thing, and I want to fix this function for the first case. Up here, it's easy. I just have to flip outer and inner in these three places, like inner color, outer color, and like this is reversed, which is nice. This is like really really nice. Um, so set doesn't exist anymore. But let make it work also for the straight case. So for the straight case, what I want to do is let's get rid of this array list and let's make it a string hash map. And inside the string hash map, which at this point, should it have a color inside? I think this can become just a string hash map of um view size, the quantity. We don't need this type anymore. Like the color is the key. So we do uh so we get or put the inner color outside, and I guess okay, we do the same twice. So we put the inner color outside, and then we try to see if there is inside, this is outer color, I believe. We try to get from inside of it a node, like something that points to the outer color. We have it. It doesn't matter, it's the count. You know what? It's the count. Let's not, oh, should I just break? Oh, whatever. Let's be nice. Get or put, which returns child res. If child res was not found existing, well, if it was not found, child res dot entry dot value, we set it to num. Otherwise, we add num. So the counts are still being preserved. But we are still going to do the first case, so we don't really care. Count nodes 2, count nodes 1. So in count nodes 1, what were we doing? We were just adding to count nodes, and then we were returning the number of bags at this level plus all their children, right? So node.contains.items.len plus count. So this was the original version of it. So here we want to do count 1. And I think I need to fix a couple of types, because can I do .items? No, I need to do the iterator thing. So var it .contains.iterator it.next. Oh, and guess what? This needs to become node contains.count. So while we find a child, do this. Maybe I should also fix this. And this gives me, this gives me KV actually. So, yeah, I'm getting key value pair. Color, child color is going to be kv.key. kv.key. Set doesn't exist anymore. Value here is not mentioned because we don't care about counting in the first part of the exercise. In the second part of the exercise, we care about counting, so that's why mentioned, and it's this. Okay. Is this really it? Let's see programming errors. Use of an network count nodes. Oh yes, this recurses to count nodes 2. This recurses to count nodes 1. Oops. $248. Was this the right number? I don't remember. No, 169. Oh, damn it. So what am I doing wrong? What if I remove this? Was this the problem? count 0. Oh, yeah, right. Huh. So that's interesting. I haven't fixed it by doing this. So why, what does that mean? Oh, I know what it means. I think I understand. I think that there was no. Oh, okay. I think I understand finally. The set step was necessary because there are no duplicates within the same array list. So changing this array list to a hash map had no impact because there were never duplicates within the same array list. But there were duplicates across different array lists. So you would count multiple times different parts of the graph because they would show up in different subarray lists. And so all this work that it is useless basically. Because at the end of the day, the array list there was perfect, but I really needed to do the set thing. The set thing was necessary. For count 1, the set was absolutely necessary. They go to back much in the past. Okay, I think this is okay. This is when I was right. Interesting. So I think I learned something. Um, my reasoning about this list was completely wrong. This is correct. This is fine given the input structure. The problem was you need to check the uniqueness because there will be links to the same bag from other bags. Obviously. Damn it. And we know that because we are the ones creating this. And we are creating this thing here by looping here, well, this continue here, that keeps looping the inner loop, is placing the outer bag, in the other version where inner outer here are swapped, that is placing the outer bag inside multiple inner bags. And those are all sources of duplication. Damn it. So the set is really necessary. Set was really necessary. Wow. I learned something today. First of all, parsing is boring. Use libraries. Avoiding using libraries puts you in front of slices, which are boring, especially when the format that you're parsing is like not really meant to be parsed. Libraries are illegal. They're illegal in the leaderboard. I know. I'm not doing it. I'm being a good citizen. But yeah, for anything, just use a proper parsing library, and you're good to go. Especially when you have these dumb formats that you don't really care about. In my Redis client, I don't have a parsing library. I do the parsing myself. But that's a format that it's designed to be parsed naturally. And also, I wasn't doing this garbage here because I was trying to build a proper library that people can use, readable, usable, more complicated than this. So no garbage like this. Also because it was based on streams and not slices. But yeah, thing number 2 that I learned is that this array list was perfectly fine, and that I really needed to do the set thing regardless. It wasn't a hack that I added on top just to like circumvent a bug that I introduced. No, there was actually a legitimate step, in my program. The point that I would say well, whatever. I don't care anymore, but it's been fun. So thank you everyone for watching. It's been nice. Also, welcome to the new people. I hope I didn't bore you too much. You caught me in the one exercise from the Advent of Code that kind of caught me unprepared because it threw at me a couple of oddballs. Like I have to admit, it took me a moment to get. Oh yeah, the one so far. Yeah, right. The one so far. Honestly, I hope that the next ones are gonna be less parser heavy. Like, please, I'm getting bored of parsing stupid formats. Just give me like this exercise would have been nicer, and I would have spent more brain power about thinking this set thing if I didn't have my brain busy by with this parsing stuff. Although I have to say, it's fair to say that the advent of code people say that you can solve these things however you want. So from their point of view, like at least at this point, parsing should be something that you can handle more easily, and you don't have to be like a caveman every single time and try to rediscover fire by banging together two index of scalar post calls. But yeah, given the rules that we have, this parsing stuff, honestly, next year I would say you can cheat on the parsing, like no libraries except for a parsing library, and so that you can save yourself some annoyance here. And I think that actually having people learn parsing, how to use a parsing combinator library, is not bad in general. But yeah, that was nice. So well, thank you for being here. Thank you, Cosmic, for the help, and also G. Piancastelli, Flandere. Thank you all for being here, and see you tomorrow for the next one. Let's hope it's gonna be easier. At least easier on me. You could write a tiny parser library yourself, right? Yeah, I could. That's true. But at the same time, it's, I don't know. Wouldn't it be still kind of cheating? I think it would still be kind of cheating. I don't know. You know what I'm gonna write? I'm gonna write a package manager that downloads Mecha. Is it cheating to use code from previous days? I don't know. I'll be honest. I don't think that like the rule that you should not use libraries should be taken too seriously. Honestly, if I wasn't doing streams like this, I would use the library. Or actually, there's another thing to say. I think there are clearly two different types of people doing Advent of Code. Like, I'm doing Advent of Code at the end of my day, and I'm not even trying to speed run it. There's people that wake up at 6 a.m. Like for us in Europe, this stuff comes out at 6 a.m. basically, and people that wake up at 6 a.m. and solve it immediately, they get points. I don't get much points because again, I would probably not be particularly up in the leaderboard either way. Like, these people are pretty good, but even so, I would probably be a bit higher if I actually woke up in the middle of the night to solve exercises. So I'm not. And my point is, if you're not somebody that is ever going to be like up here because you're waking up and being really serious at solving the exercises, does it matter if you use a library? Like, who cares about the points? Yeah, precisely. I mean, wait, the people up here clearly care about the points. I mean, Nameless and Specs Guy, I think these two are having a cold war right now. I think they wake up at 5, have like 15 minutes run, then they go on a website to start like warming up typing Red Bull, and at 6 o'clock they are ready, angry with the editor open, and and they're gonna fight each other. And I mean, it's fine, right? I mean, if they want to have this, if it's fun for them, let them have it. My point is, if you're not somebody that is ever going to really compete with the people that take it seriously, it's fine if you use a library, and you're not going to compromise anyone, right? It would be different if like you're one of the top 4 guys, and one of the rules is supposed to be don't use libraries and you do use libraries. So in that case, maybe it wouldn't be nice, but otherwise. So let's see what people are saying. Who cares about the points though? They care because they're at the top. Otherwise, they would suddenly not care. Sure, but they did put the effort of waking up early. Well, maybe not Specs. Now let me think about it. Specs is in the United States, so for him, this I think it's doing the exercises around midnight, more or less. Nameless, I don't know where Nameless is from. Yeah, midnight or just before. So for Nameless, I have no idea, honestly. So I don't know if Nameless wakes up early. I think there's other people that do wake up early though. Well, in any case, something like Firefox, for example. Firefox is in Europe, so. But yeah. In any case, I'll consider it. I don't know. It might be better for the stream for me to spend less time like mudding my way around the parsing. Just build a parser combinator and move forward with the interesting part of the exercise. I mean, let's not call it a library. You just write yourself a couple of utility functions to its parsing. Yeah. I kind of think that showing off mecha would be nice, though. You know what? I'll consider it. If things continue, okay, so let's see tomorrow how it is. If tomorrow is kind of hard like today, and there is extensive parsing involved, I'll consider just using mecha, because at least I can show off on stream how nice mecha is to use. There was so if, by the way, if you want to see mecha in action, Zig Show, YouTube, latest Zig Show time. There's this funny talk by why is this button messed up? YouTube, Google, you have one job, make websites. Why? So there's this nice talk by Matt Knight where he's actually the talk is actually about his package manager library. But the way he did the talk, he basically started solving a advent of code exercise, I think in day 2, and he started doing the garbage parsing stuff that I am doing. And then he said, and then the way he introduced the package manager was, well, let's make this an actual decent program and let's use packages that are already out there. So he tabs out from the editor and starts using ZKG, his package manager, to download Mecha, Clap, and and other packages to make the application nicer. And that was funny. So so if you want to see Mecha in action, which is pretty cool, you can see it there. But I think that it would also be nice for me to demo Mecha a little bit. Yeah, why not writing today's solution with Mecha instead of breaking your leaderboard rules? Oh, you mean rewriting afterward? Yeah, the way you stay honest to the rules and then you can showcase Mecha how much you want. That's another one. I don't know. I'm trying to like streaming today for 3 hours and a half to solve this was a lot. I was hoping for it to be less. I usually would like these streams to be like not more than 1 hour long. But hey, that's just how it went. I think it's fine. You know, I another thing that I can do is like just remove myself from the leaderboard. At the end of the day, I don't care much about the points. I just care about solving the advent of code. So maybe I should take myself out. I don't know. We'll see. We'll see. I'll consider it though. I think that showcasing like a bit of a couple of libraries might be nice. At the end of the day, this is supposed to be something for people to watch and enjoy rather than just me getting the stars. I don't care about the stars. Well, thank you for the discussion. This was interesting. I really think about everything that you people said. On the public side, you're publicly documenting what you're doing and not simply cheating with libraries. Yeah, that's true. That's true. Yeah, we'll see. Maybe I'll raise the issue in the Discord channels and see what people say about it. Well, thank you everyone again for watching and caring. It was really That was really nice. So, see you tomorrow for the next Advent of Code. Have a nice day.